Yeah, I think what the part left in this will finish today. Yeah, so previous class we have covered the basic UAV definitions, then classifications, and I think a little bit about the economy point of view, what the operating cost is coming for this type of hardwares. So today you have system composition. We will explain that. So I was here to explain this. So today we will finish this. Okay, so normally I've seen the different components of the UAV, and we will see what the details has given as per the textbook. Okay, so if you start with the system basis of the US system, like unmanned aircraft system, then you will see various type of the subsystem mostly will be integrated, which is somehow similar like aircrafts, correct? Because that this cost is nearby 80%. Operating cost, if you take, then looks like nearby again the at least 50 to 60% is there as for the aircraft. Okay, so somehow this looks like 80% operating cost as well as the design cost in comparison to the manned aircrafts. So you also got idea like where this type of aircrafts require and what is the advantage, correct, in terms of the comparing these two type of aircraft, other unmanned aircraft or the manned aircraft. So if you check the system composition, mostly we see the whole systems as a UAS, okay, and then we have to look all the points, yeah, subsystem which are coming under this to make complete this system. Okay, so we will see that. But this is the one of the important part. You should have platform. So if you're starting with the control stations, means how are you going to communicate with this system to your GCS, correct? So that is the importance. So if you start the control stations, mostly you will see the CS term, okay, and CS term can be on the ground or maybe can be on the moving vehicles, okay, or ship. So that is the idea. So if you have, let's on the ground, then we call it ground control stations. If on the board SC somewhere is there, then SCS. Okay, sometimes like maybe you are controlling the aircraft through the any airborne type of aircrafts. Okay, so there's the moving what is called CS. Okay, and somewhere you will see ground but moving, correct? That is like a moving platform, truck or something will be there to we installed all the CS controller stations. Okay, so depends how this type of control systems available and where placed to control the aircrafts. Okay, is it from the ground, either static or the moving, or it can be on the ship, or it can be on the aircrafts. Okay, so it depends on that. They're given the different nomenclature, either GCS, SCS, or the SCS. Okay, so that you have to remember. And then you have seen this diagram also, what was the functional architectures. So normally you have seen the most of the components which we are highlighting now. Okay, so what is the importance of this? I think one more point they have given. There is called if you are pre-plan, let's like your UV mission is pre-plan, then maybe one time uploaded, correct? So maybe you're not talking about the center. From the center, you have just pre-plan the software or maybe be points for the aircraft or mission, and then you are controlling, correct? So it can be, it is not compulsory. It should be just uh, your aircraft is moving around the center. This can go anywhere else also based on the pre-plan mission. Okay. So this type of mostly mission type of things comes under the mission planning and control stations. Okay, so this is also part of the GCS only. It's not like a different, but this is like a specific term. You have some mission based on the need. Okay, so need can become from the different like users. It can be from the army, navy, can be from the air force, or maybe anything, correct? If not civil applications. So sometimes you have this type of requirement, mission requirement, and sometimes CS will take care. Otherwise, you should have this information from the user, and user will be sent through the physical connections on the ground, and that will be reaching to the CS, and then CS to the your aircraft. So I think that is there in the under the communication side. Okay. So if you have any activities from the MPCS, okay, then all mission related specific things you are sending there. Okay. So did the idea, if mission may be planned from the central command center, that is there. Means if you have users and users input will be from the different source, correct? User source like Navy, Army, Air Force, and that will feed it to the central command center. Okay, and then central command center, what is there, that will take care. Okay, they will approach to the your CS. Okay, like who has this type of systems, either GCS, SCS, or ACS. Okay, that will be uploaded from the central command center, and that information which is available now to CS will be sent to the aircraft for execution. Okay, so that is the idea how mostly will work. So you have center command, center command may be available to the CS, and CS going to execute that, will be uploaded to the aircrafts. So every informations here, either you are speaking to the aircraft, or maybe the CS going to speak to the central command center. So those depends how communication systems are there. Is it physical fiber communications are there, or maybe you have radio communications. So mostly physical wire communication, or maybe any other source of the communication can be from the central command center to the CS. But when we are talking about the CS to the aircraft, when anything's happened, the aircraft, then that going to communicate through the radio or satellite communication only. So that is the uplink. Okay, so uplink side, if you want, let's specific payload should be active and require, let's tilting the camera or something for zooming that. Okay, so this type of mission you can activate, and if you want, let's those information should be return back to the CS. So that's the idea here, that is called downlink, means CS should be available to do that also, means has facilities, so that can recover the payload data. Okay, and payload data can be transmitted back to the your central command center, because of that they're asking this. Maybe central command center can take further action to provide to the different users. Okay, based on the requirement, who has need of this type of requirement, they will send. Okay, so sometimes these activities will be totally different as per the military operations. Okay, civil application is fine, someone is taking care, only you have to talk to the ATC during your flying. Okay, but all these activities, so CS is not worry about those things. Maybe central command center, they have given the details, they knows the all missions related. Only when uploading, then they will ask to the ATC. Okay, to just give the some height for the what is called flying the UAV for times. Okay, what are the times, maybe 2 hours, 3 hours, or 20 hours they're asking, they have to inform them. So this would have one type of the height flying, and then radius, like coverage radius. Okay, so if you're talking about the downlink type of the information which is coming from the aircraft to the like your CS, okay, that can be either payload related, or it can be aircraft subsystems related informations. That is the status informations. If any fault is there, is something missing, or maybe link is not there, like radio link missed. Okay, all those informations should be available. Okay, and position information. So this is the navigations related, this is the payload related, other is your sensor activities. Okay, sensor data related. So again, other thing like launching and recovery of the aircraft also will be controlled from the CS, because that is the main thing, or it can be radio or maybe the satellites. Okay, so if satellites are there and you're flying beyond of the radio systems, radio communication system, then you can go ahead with this. Otherwise, you have limited options. You should not cross the what is called your range as per the radio communication link. Okay, if 230 kilometer means you should fly within 230 kilometer of radius. It should not cross. If crossing means you will miss that. So you should have autonomous facility which can have return back options when there is no radio link. Okay, so normally options will be there. If radio link is not there, aircraft should get returned back. Okay, and other thing, if not possible to fly longer range, then only one possibility is there, you should pre-plan. Okay, means you can go ahead. So in that case you have to override over the radio link. Means if radio link is not there, but if pre-plan, then go ahead with the pre-plan if endurance supports. Okay, if endurance supports, then only go, otherwise return back. So that's the idea. Means every software in that case should be active, like autonomous activities should be active. If not planned proper way, if every flow chart is not working, then aircraft should get returned back to the launching stations. So that is the activities. Briefly, you will see under the CS. Okay, so I think you're going to remember. And rest design point of view, if you want, then you can check the various type of controller stations. I think I given the link also. You can go through that. What type of GCS systems are there? Okay, how controller station looks, and what are the design factors? Okay, either you're working with the communication system, working with the what is called GCS visual informations like GIA, and observations related. So GIS integrations, all those things are coming. Because sometimes geographical information system also supports the guiding the vehicles. Okay, if you're you will see, I think during the navigations, how the previous INS system was required the data from the ground for calibrating. Now you have a GPS, yeah, the GPS. Sometimes GIS also update to the ground. Okay, so when you don't have any information, let's, if not information available, at least flying over the screens, correct? So you have idea where your aircraft is now. Okay, so briefly, I think just capture the controller stations and details. If you want, then go through the source link I shared already. Okay, then payload, already I told payload is the important part of the aircrafts, and this depends on your mission. Okay, sometimes we design the aircraft specific for the payload as per the mission requirement, or maybe the deployment, or maybe the users. Okay, especially users. Military operations can be just for surveillance or something, ISR applications, or maybe can be armed based type of UAV. So depends. Okay, so what type of payload requirement is there in your platform, that should be integrated. Okay, so this just taking payload can be a camera, one of the camera. Okay, otherwise every other thing, yeah, application based need or sensors integrated with their aircrafts can be a payload. Okay, which not just camera, armed things also can be a payload. Okay, so extra than the aircrafts. Flying things is different, but what is the purpose you're going to fly? What is that extra attached which is not affecting the aircraft operations? Okay, just putting the systems and you're utilizing the use of that. Okay, so the applications will be different than the aircraft systems. Okay, so payload either you place or not, there is no question about that, correct? So aircraft standalone going to work for the operations except the your need. Okay, but if you place the need, that need is actually the payload, and it can be either you are expecting a camera sensors data, or any arm related, or any other activities if you want. Okay, normally you will see the payload for ISR applications. So when you're talking about the one of the payload is the camera. Okay, so camera you have seen now varying from the different size to weight, or different size and different weight. Okay, so if you see this example as given, what the range is suggesting, camera can be unstabilized. Okay, video camera which has a fixed lens, mass maybe the very small. Okay, so we are talking about very small amount of the mass, especially when you're talking about the UAV. Okay, so especially not this not mentioned for the your bigger aircrafts. UAV aircrafts. Okay, this is especially any type of the UAV, small or bigger. Okay, when you're going more than this, I think if you want let's 500 meter or 1000 meter, something like that height, then you should have little bit good capacity of the camera. So normally you will see 3 to 4 kg. Your camera also has little bit within this range. Okay, so if you like cover 1000 meter or 1500 meter approx vertically, then it's fine. It's not a bad idea. 1 kilometer or 1.5 kilometer camera range is good. So actually you are capturing the vertically down. Okay, and maybe you have some angular coverage also. Sometimes you can tilt 90 degree or 120 degree like that. Okay, so what is the coverage? 360 is fine. Either you can capture by rotating the aircrafts, or you can have at least coverage. Okay, cover in terms of the conical shape, so like angular coverage. Okay, so they are like just mentioning this can be 3 to 4 kg or more than that. Okay, this is not just like suddenly crossing 1000. Can you 45 kg, 100 kg, 100 plus kg? Okay, till 1000 kg. Okay, so normally what you will see till 100 kg payload capacity, or 100 kg type of the payload, especially synthetic aperture radar type of things you will see in the UAV side. Okay, but if you very high altitude, if you're talking the satellite type of the airborne platform, and if that have capacity till 1000 kg or more than that, then you can go with the very high capacity of the radar. Okay, that's again the camera, synthetic aperture radar. So working the maybe the different working principle, but idea is the same. You want to capture the images or maybe video, but very high end. Okay, very high what is called resolution type of the data. So normally I think you should see the remote sensing satellite related payload, then you will get the idea. Cartosat, those things you can see, or any remote sensing satellites payload, you can see that what type of camera they put that in the space satellites, especially maybe similar type of there in the aircraft also. But normally I've seen 45 kg to 100 kg type of the payload and integrated with the UAV. So I think I don't know the 1000 kg anywhere integrated or not. Otherwise you can search if any UAV is there which has this type of maybe in the plan in the future. But most of the satellites, they have capacity like this 800, 900 or approx that you will see the what is called radar. Okay, synthetic aperture radar. So we have I think one lecture over this also, synthetic aperture radar or EO type of. So that is there means variations can be from the very low gram to kg to like a ton, correct, 1000 kg. Okay, then question is next point, like this was the second subsystem of the UAV, and third is actually itself the model. Okay, so I given the link also. I think you can go through the link for the this one Heron. Okay, so you can go with that and check what type of aircrafts available from them. Okay, for different applications, they're developing the different type of the UAV for different applications. Okay, so when we are talking about this type of the platform, okay, main task is their aircraft should be stable, that is no doubt. Okay, no one will talk about then flight performance, but they is fine. If not, then you should go with the low payload capacity, or you should design the another vehicles, correct? So first idea is there, you should have payload requirement, means weight of the payload can hold, and then second is the endurance. Okay, these two is very important. If you can support, then only can talk about the range. Okay, so flight endurance and then payload, these two is a very important part when you're designing the UAV. And so how much extra weight can take, and how long this can fly. Okay, based on that, and then speed of the aircraft, you can decide what is the maximum range this can achieve. Okay, so most of time your range capacity will be very long. Okay, there is no doubt. that can be very long range. Okay, so there is no doubt we have seen the 1,000 kilometer based on the SATCOM. Okay, but 200-300 kilometer, 400 kilometer, sometimes 600 kilometer. Okay, so depends, at least 300 kilometer minimum. Okay, if you're talking this type of UAV, so 300 kilometer radius we are talking. Okay, means you should have capacity 300 kilometer going first and coming down. This much range should support. And how long you should be in the air. Okay, so first, like a basics idea is there. If you're sending the aircraft somewhere, then double of that distance time they require, and then how much time you want to be in the air. Okay, that is also important. So this would be available from the endurance point of view. And then I think if you see in this type of the vehicle design, then should have all the uh, subsystems which have communication link, yeah, stabilization control equipments, power plant, fuels, electrical power supply, getting correct. Then if airframe structures. Okay, then how are you going to be launch the aircrafts, how are you going to carry out its mission. Okay, and recovery related system. So this is all the part of the your vehicle designs, because all designs should have like options to integrate these type of systems. Okay, so we are not talking about just design point of view, but we are talking if any systems, yes, subsystems coming to integrate this, where you can integrate, how you can integrate, correct? So all those designs should be captured during the airborne design itself, like platform design itself. And then already I told you should know what is the range you can achieve and what the endurance you can go ahead. Okay, and what are the maximum speed, the speed you can achieve. Okay, because this is a very important point, because based on the air speed, like a minimum air speed required for the aircraft, you should have recovery as well as the launching systems. Without the knowing the minimum air speed for the aircraft, you cannot go ahead with the design of the launchers or recovery system. If you know only maximum, then there is no good idea, correct? Maximum is just recommending for achieving the long range. Okay, and already you know that maybe a lift generation is not creating problem, correct? Because the high speed also, but minimum speed is also important. It should not affect the lift generation because minimum air speed means minimum lift should be generated which can balance the aircraft weight, correct, including the payload. So of course we are talking the flight envelope for the airspeed. What is this airspeed we are talking for the aircraft? So that is the importance here. So I think one more point was either this can be a sky or you're capturing the data. Okay, and sometimes your camera data has software to stabilize your video. Okay, so many camera when you have seen the past in the mobile, when you're capturing the video or images was not good, correct, blurred, something like that. Now they will take time to stabilize first, then capturing the informations. So that's the software part of the payload. So that is also important here. When aircraft moving at the particular speed, yeah, highest speed, is it your payload supports or not, correct? So payload is like a how that going to capture if maximum speed you apply to the aircrafts and your payload is not good to stabilize the video or images, correct? Then what is the need of that speed? So this is all justifications for application point of view when you integrate the payload based on the aircraft speed, minimum speed required. Okay, or maybe the maximum speed recommended. So payload should not affect because of the speed itself. Okay, so these are the points you should remember, because the stabilization of the images or video is also important. That's the part of the mission. Okay, so not get blurred. And we have seen that when military operation started, then we have seen the synthetic aperture radar type of the data, which is actually not good. Okay, you can't see the persons on the ground itself. what the person holding in hand, okay, with the synthetic aperture radar itself. So when this type of herons flying at maybe 38,000 or more than that feet height, then you will see blurred type of the images coming from the synthetic aperture radar itself. Okay, so lots of people, they are looking like how to filter that, okay, how to optimize the this type of videos to get the informations. Okay, otherwise after spending this much time also they are not getting the good images or good videos. Okay, so this is there. I think I don't know, I have in some PC, but I cannot show you on online. Okay, and then I think next point is the your navigation system. So you know the function of the navigation system, which is the important point, yeah, system of the aircrafts, any aircrafts. And today we have lots of class, yeah, different types of the navigation systems. Okay, but when you think the past and today, what you will see. Okay, so in the past started with just like a navigation point, correct? Only the headings. Then just looking like a geographical informations, they can predict what, which side they are going, which direction they are going, correct? Now you have lots of equipment, either you have bearing equipment, like you have heading informations, then you have bearing DME, you have for the distance. Okay, you have a GPS related, okay, inertial navigation system. So if you compare all, maybe all the equipment are not integrated with the UAV. Okay, or maybe if integrated also, let's have at least basic idea. Navigation systems will give you the position, velocity and time, like a PVT solution of the aircrafts. Based on the PVT, you can predict where the aircraft is there. Okay, so this is the types. So first we can check if there is no like navigation system available, then what you can do. Okay, just you have to control from your um, ground, correct? Means you are knowing where is which directions you send it that. Okay, and how you going to return back till the radio link. But if you have autonomous operations, okay, so till means today now you have need of this type of system, navigation system. At least you should have informations available every time on the screens, correct? Means operator should know where their craft. Okay, so first one option will be like your radio systems, radio systems through which you will get the navigations related informations. Okay, and other you can get through the pre-plan information on the GIS, or maybe what the your map will be on the GCS side. Okay, so where their plot shadow will be on the map, you will see every time that long details will be there if GPS receivers are there. Okay, so GIS already integrated in the GPS. When you are flying over that aircraft, you will see on the GIS, means on the map, earth map. Okay, so you can predict your aircraft is this. And I think long back one of the Heron crashes in the Hyderabad somehow, and they predicted the locations from the only this one, what is called GIS, like a map on the GCS side, because the GPS was not available in those area when crashes happened. Very dense forest, they miss there. Okay, so sometimes you should have like a map. Map is always required, but most of the GCS don't have upgraded the GIS systems. What are the GIS available to the foreign country, like especially Israel, if you're talking, then they have only old GIS. Okay, they cannot capture the Indian region, correct? Only they can get from the civil type of the, yes, civil related maps. They can't get the defense related. Okay, so somehow they have restrictions to capture the maps. And what are the old maps available, they are integrating the GIS. So all GIS integrations can be from the internal security point of view. Means the only particular country they can take care on country GIS, and then they can update. So like if remote sensing satellites here, IARS is working on that, ISRO is working on that. They have good map all over India, and then they can integrate. Otherwise, you can check the Google's other map if also. Some area maybe you will see the good quality of the maps or images, earth map, and some where you can't see the good quality. So what is the reason? Means the GPS available those area is not capturing the information. Okay, so you should have very high in type of the radar available to capture the data. Okay, so this type of things comes under the remote sensing satellites. This is not coming under the your GPS related information, because that will give you only lat long, not your maps. Okay, so if you want map, means you should have a synthetic aperture radar integrated with the satellites. Okay, and that can capture the area, which is like a specific country operations. Without permission you can't capture the data. Okay, so this is the idea. So of course JS is also important when you have pre-planned mission, because you will see every point on the screen. And then in other words, like your INS system, inertial navigation system. So long back when I started the inertial navigation system, they need very high sophisticated type of the INS. Reason was because they have to update, like a calibration of the inertial navigation system was very important part. So that time maybe the GPS or maybe the receiver, GPS receiver was not cheapest. Okay, so maybe in that case you need the information from the ground to calibrate. Every time you have to calibrate, means you should have INS data available through the GCS. Okay, then predicting from the your reference point using the speed of the aircraft and time, integrating further, and then you are providing the again similar type of data to the aircraft for calibrating. Okay, so this was very complex, means complex, expensive, heavy in a system, because these activities should be completed on the aircraft on the board. Okay, otherwise very tough, because inertial navigation systems with the time, okay, will give you the error. Okay, so integrations, you will see the twice integration is there, every integration error will be there, and if not calibrated within the short period of time, that error will increase. Okay, so that will be very large. So if you want to update the INS data, INS informations, then you should have calibrations information available there itself. So there was a need how you will get that external source to calibrate that. So I think when GPS came in the picture, today your GPS, DGPS, IDGPS, getting correct, server client based GPS, many options are there. IRNSS is also there for at least for India. What is the India extended area is there. So those services are there. So normally you have seen under the GNSS, lots of receivers are there, and receivers are very cheap. So that is integrated with their aircraft. So most of the aircraft today has this type of system, and from GPS receiver they are accessing the all the details geodetic in the geodetic system, latitude, longitude, and the altitude, and this can give you the positions in X, Y, Z. Like if you talk about the Cartesian coordinate frame, then you have position information as a X, Y, and Z. So geodetic system to the Cartesian you can convert, and that information you can pass further to the inertial navigation system for the calibrations. Okay, so because the GPS system's availability, yeah, GPS receiver availability on the aircraft, now you can go ahead with the cheapest type of the inertial navigation system as well. Okay, because this does not require any external source which require from the ground. Okay, because already on the board GPS receiver is there that can take care. Okay, so every time INS should be calibrated using the GPS receiver. If a GPS receiver, yeah, GPS related systems does not give any informations, then INS information should take care. Okay, so that is like dead reckoning system. This is called like this that time this does not require any external source. Okay, so in during the short period, why GPS uh, only is not working, why INS is only not working? Okay, why we need both? Okay, question is there. So if you want like let's only GPS should work, so what is the problem? Within short period of time, okay, when you start the GPS, then what you will see, there is a error. Okay, so error will be during the short period of time in the GPS receiver. but with the long time, like when period is started, yeah, going for longer period, then INS gives more error. Okay, so for short period, GPS receiver gives more error, and for long period, INS system gives more error. So that is the compromise. Means if you have a GPS receiver, for short period you follow the INS, because during short period integration error is less. Okay, so INS performance is very good, but with time GPS receiver is very good, because that will get the maximum satellite coverage, and maximum satellite coverage means good positioning, means what is called VDOP, correct? VDOP, yeah, dilution of precision. If you're talking about vertical dilution of precision, horizontal dilution of precision, then you should have a good DOP. Okay, so when you're talking about vertical type of the accuracy, then horizontal accuracy will degrade. When you're talking the horizontal accuracy, then vertical accuracy will degrade. So you cannot predict for both accuracy at the same time. Okay, so very important point this type of there you should have. So why we need the good DOP? Just to make accurate informations. Okay, and how you will get the good DOP? When you have maximum number of satellites detected, and that has farthest distance. Okay, so when the receiver detects at least minimum 4 satellites, they should pick up the maximum volume made. Okay, so if you receiver is 1 point and take another 4 satellites, then how spreaded very large distance. Okay, so you will make the bigger volume, and bigger volume is actually, if that will give you DOP. So DOP is inversely proportional to the volume made by the satellites and the receiver. Okay, so only 4 satellites is enough, but we are taking like every time should have good coverage to make sure that the DOP should not degrade. Okay, so this is the idea. I think if any problem is there, because the DOP also, you should have at least a reference frame, like one of the receiver available on the ground, which is also calculating the same informations at the same time. So let's see DGPS, how DGPS works. Mostly one of the receiver will be installed at the non location. Let's Manipal, correct? You locate one receiver in the Manipal, and your aircraft flying maybe the Mangalore, correct? Nearby the Mangalore. So mostly within 100 kilometer there is no error. Very less error will be added. Okay, so you should go more than 100 kilometer. Now Mangalore 65-70 kilometer. Let's consider time being is crossing the error, correct? Error which is recommended for the DGPS. So what is the idea? Receiver detecting the same satellites in Manipal also, and in the Mangalore also on the aircraft side. Okay, so both has the same receiver data, like which coming from the GPS, and both are calculating the position using the same data. Okay, because data is coming from the space, so of course we'll do the same time calculating. So what you will see, the position calculated at the same different locations are not same. Okay, so at least who will calibrate in that case? Only the ground station will calibrate. Let's Manipal has location, geodetic informations, lat long altitude, correct? From the sea level. So what you will do, you will use that information like non-informations, and what is the predicted from the receiver, you will compare that, correct? So after comparing you will get the error. Okay, this is the non-error, and this error will be transmitted to the aircraft. So that is the idea how the GPS works, and that error which is available from the Manipal ground stations can be taken care as a um, can we take as a what is called error accumulated in the aircraft calculation also. Okay, so after subtracting there, you have actual positions of the aircrafts. Okay, so that is working there, and I think there is called server client based also. Sometimes if GPS is not available but internet is there somehow, if internet is available, then through the internet you can predict what are the satellites will be there nearby that. Okay, so you know that constellation of the satellites in the receiver will be there. Okay, so if you have GPS and 24 satellites active for the this type of there. Mostly will be 32, I think 28, 29 operation now, but 24 minimum require. Okay. So if you're getting, okay, this particular area, these are the satellites should be available, correct? From the internet also. So receiver will pick up only those satellites in the receiver itself without getting any external information. So what is the meaning of this? Meaning is there, first you locate your satellites positions. Okay. So once you locate, then just you make active. If active, then I think you will be using that basics idea to calculate the positions. Okay. Otherwise, every time you have positions of the satellites known, then distance like covered between the satellites and your receiver. Okay. So that is the idea, means getting the data from the internet and knowing the satellites positions and your location distance from the satellites, you can use for what is called position calculation in the receiver side. So this is very smart today. People are talking about the different type of the GPS systems, and normally this require in the what is called automotive sectors. Okay, for us aircraft is fine. Every time aircraft will be in the air, so there is no problem except rain or any other factor if they are in the night side. Okay, so that is the idea here. And if you are talking non-autonomous operations, okay, we are mostly communication believe from the your of what is called radio link, and we expect every time continuous communication is available. It can be a real or virtual possible. Okay, but what is the region? What is the problem? Okay, when you are using the radio link, okay, like you are controlling the aircrafts, like this type of aircrafts. So problem will be if someone going to use that radio link, and they are also passing the informations. So if they will block the GPS, then will be so. Okay, so this is the idea when you are looking like a radio link communicating from the ground. So it is very secure, safe and secure, because that till today people are working to design the secure communication system for the Heron itself. Okay, because nothing is available. Okay, nothing is available from the OEM side, means you should work on that. You should have your own code. If someone is giving, then you know that, correct? They know the software, they can decode and they can lock also again. Okay, so if you want to take control over the communication, okay, at least physical system they are not going to create a problem, but your software they can create a problem, correct? So if you have control over the software itself, then you can make the secure communication link between the aircraft and ground controller stations, at least payload side. Okay, because OEM if already has given the system to you, of course they are not creating any problem. But any third party, if they have this similar type of the communication system or GCS, okay, they can interfere. Okay, they can predict those informations and they can pass when they are knowing you're flying their crafts, correct? So normally uh, OEM is not restricted only for few users. They can sell to any other users also. And if you have similar type of system, then other they can do that, correct? Other they can try to hack the systems. Okay, they can at least they can damage their crafts, or if not possible, at least they can access the payload data, which is not good for the security point of view, national security itself. Okay, so when we talk about the communication, we talk like your telecommand as well as the telemetry, and payload is also part of that, correct? So telecommand, telemetry and payload, this should be secure. Okay, and if you secure the telecommand, okay, then at least you can control, you can make a secure communication to control the aircraft. Okay, no one going to control your aircraft at least. If you secure the telemetry, what the aircraft details are coming, that is not going to leak to any other one. Okay, means your details about the sensors, detail about the GPS informations like locations, those things is not going to capture by the third party. Okay, any hackers or any mm, other country related enemy. Okay, so those things, if you secure the your payload itself, what the payload data is coming, is it video or audio or maybe the images, those things will be protected. Okay, so this is important part, you should know what the frequency range you are operating as per the frequency band your spectrum allotted to the country for a specific this type of operation. Then you should know the transmitting power. What is the power you want to transmit should not affect the others. Okay, and how secure. Okay, what is the cryptology or cryptography you are talking about that. Okay, so what type of the software you're going to design after communications and before communications. You getting correct? Means one side, like when you are giving the signal from the GCS, of course should be passed through the cryptology, like encryption code in your encryptor, and then if reaching there, then decryptor should be on the aircraft. Okay, so that will detect your data, and after decryption that will give into the aircraft. Once aircraft from the aircraft like transmitting the signal, then again require the encryptor on the board, and then you need decryptor on the ground. So encryption, decryption both should be there available, and this should not be known by the third party. If anyone knows your encryption code, they can try to decode. Okay, and at least they can try to break the code itself. Okay, so that is not recommended. So all security related, like especially cryptology, cryptography, these things should be within the what is called organizations or the user side only. Okay, so not they should not depend on the third party, because if you're giving to third party, they are at least they are knowing about that, correct? So anyone can can create problem in the future. So because that they need the specific workforce for working this type of area in the organization itself. So that you have to remember how this especially navigation system is a part of the communications, and is a part of the security related. Okay, so everything's interlinked. Either you talk the navigation, you talk the GCS, you talk the communications, or you talk the supported software for this communication protocols, those things. Okay, so in the navigation part, if you go further, I think you've seen the GPS, you've seen the INS, you've seen the GIS, those things. So what are the techniques they used, correct? So already told the radio related or maybe radar or direct reckoning. So this is the radar tracking. Okay, normally you've seen the radar, which will be a scanning like a data or ray emitting from the controller stations. Okay, so sometimes I think in the lab if someone seen antenna tracker, correct? So that is the also part of that only. So if you have radar will be very high end type of application, which is very high strong wave or beam going to transmit in the air, and always transmitting towards the UAV, or maybe at least rotating 360 degree. Okay, so any times if your crowds comes under that, then you will get capture. Okay, so of course we need very high end type of the radar. If like a 300-kilometer range you are flying the UAV, means at least you should have beam till 300 kilometer. Okay, beyond of that mostly will be like your what is called pre-plan only, mission specific type of operations. But if you're talking like a flying within the radius, okay, then I think radar tracking system of course will work. And that radar systems once reflected back, because that will hit first the aircraft and returning back. Okay, so transponder will respond that what is the signal returning back, and based on that they will creating the your what is called the position on the screen. So screen will be available like a CS radar display, where you will see the bearing angles, okay, from the reference, and then range how far away your aircraft is there. So this is like your radar theory, correct? Radar theory, transmitting the signal, and once returning back, then you're capturing that, finding 2D by T, or maybe 2D by total distance traveled by the time half, because you will capture only total time, okay, transmitted to returning back of the beam, but distance covered will be twice. Okay, first going to hit the aircraft, then coming back again. So this is a twice distance, so 2D divided by T, or you can tell D divided T by 2, so T half. So this will give you your velocity, or maybe you can have some other information also parallel with this. So displaying, so you are getting the distance like a slant range directly, what is the range you are capturing, and then from the reference what are the heading or maybe bearing angles you are talking about that. So this is like a polar coordinate frame. You will see this type of radio tracking side. I think already you know that mostly every time you have a radio link between the aircraft and then controller stations. So of course all the data is coming, and another thing like parallel, when you're transmitting signal or coming back, then you have time range also. So based on that also you can decode. Okay, so these are different type of the techniques. I think you've seen the this one, what is called ADF type of the equipment, ADF, then VOR, or then DME. Okay, so sometimes you will see the time is also important. What is the time transmitted the signal? What is the time received the signal? So if you can decode that, and after decode you can find what is the distance traveled and how much time has taken. Okay, so those things is also important using the radio link type of the equipment. So then this called dead reckoning. This is called direct or dead reckoning. You can tell this is nothing but what is called AHRS, like a heading reference system, which is in the INS system. Okay, advanced INS system, because AHRS will give you the redundancy in the sensors, like 3 sensors in each axis. INS system has single sensors in each axis. So accelerometer, gyro, and magnetometer. Okay, so in the INS system we never talk the axis. Okay, we talk 3 sensors with the processor and the estimator, Kalman filter, or any good algorithms to predict the informations. But AHRS has advanced than the INS because every axis has these 3 sensors. So comparing every sensors with the other access sensors. Okay, so you have at least a good sensors data available on the board. Then again you have very good processor with the good software to predict that, like estimator algorithms. Kalman filter will be common to all this type of equipment. So this is called dead reckoning because this is not require any external source. Okay, so what this will do, if you have position on, like what are the positions and what are the velocity, what is the time on the board, then just you can do the integration operations, so basic integrations. And if you want to calibrate also is fine. I think I explain basics how mostly will calibrated. Okay, so if you have GPS then fine, otherwise GIS information, those things also can be captured. Okay, then a very important part is the launch, recovery, and retrieval equipment. Okay, what you do once you launch, you should get recover. Okay, and somewhere retrieval, like any accessory other than that one also capture. Okay, so if we are not talking about the vertical takeoff landing, which require very small short runway, very small space you can tell based on the aircraft, like a what is called a ground effect. And so how much area you are looking. Okay, you cannot fly nearby the hilly area if you very near you park or something like that, correct? So at least you should have basics space required. So your aircraft should not get affected as per the flow analysis. Okay, otherwise if we are talking this totally different VTOL side, but beyond VTOL means if you just avoid the VTOL, then you have need of the launching systems, correct? So launching systems can be a runway requirement where a wheel is required, correct? You should have a wheel attached with your UAV systems. Okay, and mostly you've seen lots of tests going to happen based on the speed and then load acting on that, because that both going to transfer in terms of the friction to the wheel, correct? And friction in terms of the heat, and heat in terms will again the fire, correct? So that should be hold that much temperature. So there should not be any problem. So of course your wheel is the part of the launching systems. Okay, this is the need of the runway side here. So main idea is the runway requirement. Okay, if you leave the runway also runway requirement, then next phase requires some launcher, different type of launcher. And launcher, you've seen mostly people design the small launcher. Okay, some like spring based type of equipment you will see where you're going to place your aircrafts on the launching systems, and then you're pressing the some force through the spring, correct? Then that force going to transfer to the aircraft, and then aircraft maybe will be in the air. Okay, so what is the minimum requirement in this? You should have the launcher speed such a way that can be transferred the aircraft with the minimum speed required. Okay, if minimum speed you cannot achieve because the launcher is not used that for the specific aircrafts. Okay, so of course this is also very good idea. Most of the places people are using, if you have aircrafts. Okay, so okay, so of course you need a very clear environment, very clear area for this type of equipment itself in place of the runway. Okay, now recovery point, if you check the recovery also, recovery can be a runway requirement for, again, when you're using the runway vertical, again there is no question, vertical takeoff landing. Okay, but if you want if you use the launcher, then question will come. Okay, so use the launcher, fine, launch, but when you recovery, we don't have any options. So people have tested various type of the things. Either you have parachute. Okay, parachute means you can deploy that. So most of the design in the parachute such a way that they make what is called a stall condition. Okay, so when your aircraft get a stall, okay, then only aircraft will fall. So parachute is not like uh, from the back on the way your aircraft is coming, it nose is coming, your tail is coming. Okay, so sometimes this is also critical today. Now people have started to test this different way. So I have seen one or two small UAV which was proposed to the government. They tested different way. When they make the stall during the recovery, what happen? Airbag will get deployed. So parachute is different, but airbag get deployed. And once you coming down, then there is a variations of the mass, CG variations, and till like your ground, what you will see, your airbag will down, and complete aircraft will be in the wing level. Okay, so it's not touching with the any wing side tip of the wing, or not touching with the tail, not touching with the your nose also of the aircraft. That coming down on the what's called airbag system, and being in the level. Okay, so that people are testing for a small, I think 5 kg 6 kg they have already tested this type of design. So this is there, and then I think next other will be the net recovery, mostly in the seaside. What you will see, seaside mostly they use that. So you have very big net, and a crowd should get hang in that only. Okay, so once hitting to the net, that net will get capture that, and then aircraft will be floating in that. Okay, so when design the net recovery, then you should have very good guidance system. Okay, like a complete autonomous, you are talking landing things. Okay, so like they should predict proper what is the your side slip angles, what is the your glide slope angles. Okay, there is no equipment, but aircraft should track that center line of the runway, center line of the net, and then vertical what the height of the net available. Okay, So very important when you're using minute recovery. So your guidance system for the landing is very important part of in this case. Okay. And I think one more point they've discussed somewhere, they use the trolley type of the moving platform. So once landed, the aircraft speed will be transferred to the vehicles. So because of the inertia of the aircraft, that aircraft will be just touching the what is called moving platform, and moving platform will be running over the runway. Okay, so that way sometimes they are going to recover this type of aircraft also. So that you can get a little bit more idea if you can check with the launch, recovery, and retrieval for the different class of the UAV. So this is another point, like a retrieval equipment. When you want everything has done, but if you want to get back your systems, then you should have transportation related facility from launcher to your hangar. Okay, so that is there, some part always come under this only, because this is the recovery not from the air but also from the your what is called deployment location to your actual hangar site. Yeah, so I think in the communication side, what we are talking now, either the radio link or the SATCOM. Okay, so already previous class I told, normally what you will see from the your what is called runway to the GCS, there is a physical connections, physical wire, like a fiber optical communications, which will connected from the RC to the GCS. Okay, so pilot will take off the aircraft. So for taking off, what they will do, they will give all the command to the GCS. Okay, not like your transmitter going to give directly to the aircraft. So transmitter data will be transferred through the cable to the GCS, and then GCS will be uploading the data through the antenna to the aircraft. Okay, so that you have to get idea. Normally when you're flying the UAV, you have direct link, like your receiver will be on the aircraft and the transmitter in your hand, like RC. And then you're just controlling the aircraft from your hand itself. So you're not sending signal to the GCS, and that signal is not coming from the GCS to the aircraft. Okay, so that is the important part. You should have this type of link only. You should transfer your pilot data to the GCS, and from the GCS to the aircraft. Okay, and same during the landing also they do that. What is the control? Yeah, what are the stick operations should be in the pilot side, the operator side, should be feed it to the GCS, and GCS is going to feed it to the aircraft. Okay, so in that case, like aircraft should be flying nearby the runway. Okay, otherwise your operator is not going to take care. Okay, so one or two crashes happened. Yeah, there is no doubt. I think already I mentioned one of them, and sometimes they will confuse who has the mistake, but they will analyze. Okay, using the GCS data recorded what is there, what happened. Okay, so because that sometimes very risky operations, this type of things are there. Only if you have very long experience to fly the UAV, then only will you recommended to fly the bigger UAV. Okay, so one of our 2-3 people I met already in the college when some people was here. Yeah, so when you talk the communication system in this, then two term comes, one uplink and then downlink. Okay, so these two is a very important point. All communications design will be based on the uplink and downlink only. It can be there is sometimes we called budget link budget. Okay, so link budget I will be explaining during the satellite classes. Okay, I think when we will be covering little bit the satellites details. Okay, then I will be explaining how uplink and downlink link budget explain. Yeah, designed. Okay, so here just we are telling like what type of data, if not type of data, at least what are the communications going to happen and what is the flow. Okay, is it coming from the ground to the aircraft or aircraft to ground? So uplink always will be from the down to up. Okay, that is the meaning uplink. Okay, So this will be from the your controller station to the aircraft. Okay, and what is there? Transmit flight path tasking, which is then stored in the aircraft automatic flight control systems. Okay, so normally what happen? Maybe when your aircraft on the runway, they will do all the pre-plan, correct? They will do all the pre-plan, but they are not going to upload because you are not doing the autonomous takeoff. Someone is going to take off. Okay, after takeoff only when reaches the particular waypoints, then only you are uploading the your autonomous data, correct? Pre-planned data. So when you see the here on type of the aircraft's flight, then what they do, they will be ready with all the mission plan. Okay, and they will be uploaded to the aircraft also. Okay, only thing is that RC going to take care first for takeoff. Once takeoff, then operator what they do, like UAV pilot what they do, they will switch to the GCS. Okay, so when switch to the GCS means there is no control from the RC now. Otherwise, they are not going to take care, because if RC is active, then your GCS can create a problem when they are given the different commands, correct? So like a two command you are passing. Because of that, they have made such a way that every time if command passing from the ground to the aircraft should be only single, either from the RC through the GCS or only GCS. Otherwise, let's like scenario when you have GCS a different location, like what we are flying, correct? Mission planner one side and then RC another side. So like RC is also giving a mission side, also someone has given the command. So what happened? Aircraft will detect two commands same time. If both commands are different, then aircraft will get confused. If anything's happen with the autopilot system, then it will create problem to the aircraft. So good thing is that you should have single route only. So let's RC is giving the command, then that going through the only CS, then CS is knowing about that. If CS is giving the command, of course CS knowing about it, correct? So that is the good idea, means you should have only a single route to pass, either RC information or the CS informations. Okay, so all this will be uploaded pre-flight, and only thing is that once takeoff happened, okay, after reaching the particular height or maybe the particular heading, let's say at least particular heading, then your RC switch will be what's called handed to the CS. Okay, and then CS will activate the what is called pre-planned data. Okay, once like a pre-plan already was uploaded, so there is no dot. But if you want dynamic, let's dynamic point you want to change, like let's suddenly your what is called command controller centers told to you, no, I want this particular area, and that time you have already preloaded different waypoints, correct? So that is the dynamic waypoints, means based on the need you can predict, okay, now where is the your aircraft and what are the waypoints you can change. Okay, so just you're dragging the waypoints on the screens. Okay, so you're dragging that, then you're uploading. Okay, so this is like a dynamic upload in the flight, during the flight itself. So mostly this happened, this all tasking will be happening from the ground to the aircrafts. So when you want to communicate from the ground to the flight control system of the aircraft, you should have a link, a communication link to provide this. And this is working in the transmit real-time flight control commands to the FCS, automatic flight control system. And this is called, in this case, you need some persons involved. Okay, otherwise if pre-plan, then there is no man in the loop required. Okay, because already you have uploaded. Okay, but if you want like let's say real-time flight controls commands, like every time you want to change or something like that, then you need this type of activities. So transmit control commands to the aircraft mounted payloads and necessary. Sometimes you require to control the aircrafts like a FCS, and other option you require to control the payloads or any other sensors, yeah, subsystems related to the aircraft for safe operation, correct? So that is the idea. And then transmit update position information. This is the dynamic informations, means if any demands comes from the command send, what is called center, then you have to follow that, correct? So if any waypoints update require, then you can give and you can upload that. Okay, so these are informations actually going from the CS to the aircraft, so we called uplink like informations. So downlink will be the same, only there will be some reverse things. So downlink side, what you're doing, your aircraft data is coming from the aircraft to the CS. Okay, so what that will come means aircraft will transmit the positions data to the CS when required or relevant. Okay, then transmit the payload, either image or video or any other informations, payload related information, to the controller station. Then controller station will transmit the data to the command controller centers, okay, like users. So only CS may not be the user, that you have to remember. CS is the operator. Okay, so CS is not user here. CS is just flying the UAV, capturing the data, and that data providing to the your users, yeah, other users who need this. Okay, and data can be either live if you within the range, because payload may not support for longer range. Let satellite communication only work for the telecommand and telemetry. Okay, is not supporting the payload, because payload data is totally different. You have different communication protocols. Okay, so if your payload data is not working with the longer range, then what is the need? Okay, why you want to fly? Then only one option left. You fly the UAV, capture the data, okay, and then when you are returning back, then you retrieve the data, okay, because that will be link after coming back. Okay, then you can download and give to the users. Okay, so that way you can manage. Otherwise, if your payload communication is not supporting for longer range, then there is no use of that for the dynamic requirement. Okay, dynamic requirement means you are in the operation every time you need a data, okay, and you are not able to give. Okay, so that is there is no need of that, especially military operations. When I need now, I want to check all the scene or scenario during the operations. Okay, then you are not giving, correct? So that is not good. So you should know that what the range of the your UAV can fly and how long your payload communication will work. Okay, or range of the communication will work. So that is also important point. So mostly people will rate your aircraft communication in terms of the payload. Okay, how long you can provide the payload data. So that is the your range, not your flying range of the aircrafts. Flying range of the aircraft can be double of the your payload communication range. Okay, so this is the important point you should have. Side, I'm not sure is it they are giving the payload data, but only telemetry telecommand I know they are uploading the data. And if SATCOM supports the payload radar, synthetic aperture radar, then it's fine, that can be captured. But the need is different. Everyone has a different maybe SAR integrated in the future. Then maybe that SAR data is not passing directly to that type of the SATCOM options, correct? So if payload data can be transferred to the satellite, and from the satellite you can this ship, then only you have options to fly for longer range or fly for the range required for the payload. Then another transmit the aircraft housekeeping. What are those? That is the sensors data, fuel state, engine temperature, those things with the controller station. And then level of electrical power, complexity, processing and antenna designs. If you check all this, the range of operation of their vehicle from the transmitting station, sophisticated demanded transmission down of the payload and housekeeping data, the need for security. So all this design can be determined by these are the factors. Okay, either go with the electrical power, yeah, processing power requirement, antenna design, all those. Okay, so all depends on this type of, either you talk about the complexity, weight, or cost of the equipments required for this. So you will see the various type of radio communication system available in the market, which has a different data rate. Okay, different data rate. And this type of synthetic aperture radar only work in the digital form, not analog. So only what the Ethernet can support. Okay, so like if you're talking about the Ethernet cable, So Ethernet cable, what is it 2 Mbps or something like that can support. So what is the Ethernet cable can support from your payload, like your camera to your communication system, also important. If you're talking about the fiber communication, what the maximum can transmit. But normally if you're digital, then you should have Ethernet connections, and Ethernet connections how maximum data rate can support, only that is the you can consider under this type of communication system. Okay, because in a house also, yeah, on the board you have a physical connections with the camera and your communication system. So communication system and camera, communication system may handle for a high rate, but what about the physical connections? Is it that physical cable can support that much data rate or not? Okay, so that is important. Okay, so mostly people will work on this type of all. Payload may be very fast with the very good software which can stabilize, okay, capture the data very stabilized way, okay, or video transmission. So all those things, correct, and then that will transfer through the cables. So cables should we handle this type of data rate, and then at the end what the communication, what is called your board, your processor board going to use for communication protocols, okay, that also should handle this type of data rate. Okay, so it should be very fast, correct. I have, there is no doubt, till Gbps data rate available, because that people are talking computer visions, high visual navigations, that type of the communications. Okay, yeah, radar operations. So main thing is there, you should remember radar processing is very complex. Okay, a huge data you have to process. So of course synthetic aperture radar data you cannot open everywhere, you cannot open in your system. So you should have very high sophisticated software to analyze that. Okay, you will see very different type of the images, very different type. Okay, you can go to the IIRS and then check what is the synthetic aperture radar type of the images looks. Okay, you can see the picture, you can't upload the data in your laptops. Okay, can't open. So you need a supercomputing facility type of the to process those type of radar data. Okay, especially these type images are coming, so your payload itself can handle that and only require what type of image user can see. Okay, so only those images, yeah, user specific data is coming, otherwise all processing going to happen in the camera itself, because of the that cost is very high. I think 1.5 crore, just like you will see within 3 kg or 4 kg type of camera. So you can analyze, if you go with the 100 kg or 200 kg, then what will you cost of the your payload itself. Okay, so I don't think within 5 crore 6 crore you will get any type of payload, yeah, high sophisticated radar type of camera. So interface is again important. I think all this should be integrated to each other. Okay, so what are the system you have seen, if not able to interface through the connectors or through the what is called the data flow rate, then there is no use of that. Okay, so you should have very sophisticated interface in terms of the physicals, like mechanical designs, and in terms of the softwares, okay, like a communication protocols. So all are integrating to each other. So one, we can talk about the physical integrations. So everything should suit with the physical designs. And if we are talking about the electronics and the software point of view, then we should have a very good interface mechanism between the sensors and your board, communication board available, or maybe any other sensors, yeah, LRU available with another LRU interface. Okay, and then next interface is your onboard to offboard. Offboard means on the ground or a space, any communication related, like from the GCS or from the satellites, those things, correct. So that is there. And throughout this scenario, either navigation, communication, there are various types of the protocols going to work for the interfacing. Okay, so I think details I'm not going to discuss, but you should remember interface is also a very important point of this. Okay, so I think you can read a little bit. There is called a term called network centering architecture, where you will see the various type of the users will be involved. Okay, if you have something something called user applications, either military operations. Then you will see Army, Air Force, then Naval, terrestrial any objects also want to map with this. Flying object you want to map with this. A naval any object want to map with this. Then in a space system you want to use that any ground airport equipments or maybe airborne equipments you want to use. So all these are working, correct? All these are working for the specific application. Can we civil applications or military operations? Based on that, you will see a simplicity of the this type of network. But the network is very huge. Okay, network is very huge when you're talking about the high end type of the application or deployment. Okay, so I want to discuss too much over this type of systems. So transportation is important part, and if you see the support equipment, you need the documents, correct? You need the manuals, maintenance manuals, operating manuals. Okay, any type of test tools, jig, those things for further, because you have to disassemble, then assembling. So many times what we do, we have to disassemble the complete aircraft in multiple parts to just take the aircraft from one location to another locations. Maybe 5, 6 or 7 truck or maybe vehicles going to use for this. Then we need the minimum crew members to, or maybe engineers to disassemble or integrate that till the operation. Okay, so all those comes under the transportation and then support equipments. Okay, so support equipment already have seen, and then transportation side already have seen how going to launch and recovery all the system, or how you're going to take one location to another locations. Yeah, so I think this is just like your working environment for both, not only for aircraft but for the crew members also. Okay, because those people will be operating the systems on the ground, so all should support. So all weather, either you're talking about the staff point of view or talking about the system point of view, any factors related to the environment should support for the system operations. Okay, so you can look like a temperature, pressure, or you can check the weather conditions. Okay, all those things are coming under the environment. So I think this much was there under your UAV related basics, and then other class basics will be the design point of view. I think this is the design of UAV system. So brief again, what is the conceptual designs, what is preliminary design and detailed design. So every design, any airborne platform, if you want to design, you should have these are the phases. Okay, so I think next class we will be covering this. We'll finish this second chapter, and third chapter we will start with the next class. Okay, so next class you are going to read this chapter second. Any question? Okay, so we will meet next class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.